Okay. Suppose we have calculated this AHU capacity for the left side, and we already calculated, and for example, the total capacity we got as 63.6 TR. Okay, so I'm just assuming that, I'm assuming for the sake of our calculation, chiller calculation, let us understand that even our right side calculation is also exactly similar, 63.6 TR. Okay, and suppose this is my ground floor, and likewise we have, how many floors we have? Suppose first floor, we have 6 floors totally. Okay, so I'm just assuming, I will be just making one basic drawing here. So just give me a moment. Suppose this is my, I'm just trying to make one block diagram here. Okay, suppose from, so what I'm trying to do, I will just show you. These are my floors, for example. Okay, this is my ground. Suppose we have two basements, right? We have basement 1, basement 2, and suppose our chiller is situated in the basement number 2. So this is my basement 2 plan. So for example, we will just create one schematic drawing, a simple schematic we will create. Suppose this is my basement 2. This is basement 2, basement 1, ground, first, second. Now after second we have, okay, still we have, this is 1 floor, third, this is 4th floor, this is 5th floor, and for it, totally there are 6 floors of building. Okay, so this is a basically this is 6th floor building. So suppose this is my floor number 6, and this is my terrace. Am I right? Basement 2. So this is, suppose for example, my now first, if it's better that if we write down, this is my basement 2. So I'm going to write down here basement 2. Just a minute. Okay, so here I'm going to write down the basement 2. Okay, now same, I'm going to copy. Suppose this is my basement 1, ground floor, first floor, second floor, third floor, 4th floor, 5th floor, 6th floor. This might be my terrace, but let us see. So if I write down, just mute it, please. So this is my basement number 1, and this is my ground, for example, and this is my first, this is my second, and this is my third. So I'm just writing the floors here, and this is my 4th floor and 5th. This is 6th, and this is my terrace floor. So we don't have this floor here. Okay, suppose this is the last floor, and for example, here I have cooling tower. Okay, now right now what we are going to do here is, first we will do our basic what you can say, we will create our basic schematic first. Okay. Now, suppose this is my chiller plant here. Okay. Now, what I need to do once again, I need to do some more things here. Now, let us assume, see, we are doing this first floor, right? So let us assume that in first floor, from ground floor onwards, we have the 2 units. Okay. 2 AHUs. So I'm just assuming here. Okay. Because we don't have that much time to do all the floors calculation. So let's assume that we have 2 number of AHU rooms in every floor. So what I'm going to do, see, and I'm going to take the same capacity here. Suppose, for example, we got the capacity of how much capacity we got? 65 ton. Suppose I will take one area, I will take 65 ton. Okay, and let us assume, see, this area is 65 TR, and this area, let us take some higher side because we have one AHU room here. So let us take 100 TR here. Just assume it. Okay. So suppose on the right side, I'm getting the 100. Instead of 100, I will randomly write 105 TR. Okay. Now, the same I am going to copy for each and every floor. Okay. So, same capacity for first floor, same capacity for second floor, same for the third, fourth, fifth, and sixth. Okay, just mute it, please. Okay. Now, you have understood the concept here. Like what we are trying to do here is we are trying to do the pipe sizing, and we will see all the calculations and all. So, okay. Now, let me just give me some moment here. So, I'm going to change certain things here. Suppose this is my red color. Even this is my red color. Okay. And this number of floors, what we have given here is, so I'm going to change to cyan color, and let us keep it as it is. Suppose I will make it magenta color, and this side we will make it some yellow color. Okay, anyhow. Now, what I need to do means, see, I have to create the equipment schedule here. So now understand the concept here. Okay, just I hope you understood the concept, what we are trying to do here. So randomly, I am going to create, not randomly, whatever the schematic we have created, we will create for each and every rooms here. Now, AHU GF LS, AHU GF RHS. Okay, next AHU FF LHS, AHU FF RHS. Okay. Similarly, first floor, second floor, third floor, fourth floor, fifth floor, and we require one more, sixth floor. Okay. Now this is my sixth floor. So here I will write 1F. Okay, sorry. This is my ground floor, right? This I will write 1F, 1F, 2F, 2F. 1 minute, ground. This is 1F, sorry. 1, this is 2, this should be 3, this is 3F, this is 4F, this is also 4F, this is 5F, this is also 5F, this is 6, this is also 6F. Now, this is going to be same for all LHS. So straight away I will copy all the LHS side. We are assuming the same. Now for RHS, we are going to change. So, okay, this floor I am just, we will write it later. Now for RHS, what we are going to do means, see. So we are going to copy this. This will be my right side. So for right side, we are assuming how much? 105, right? We are assuming 105 here. I will just change 105 and supplier CFM. So I'm assuming the supplier CFM also here. So the same concept, same formula I'm applying here. Let us see what is the formula it has taken. Suppose it has taken 522. So suppose I'm just, for the sake of our calculation, I'm taking this much of supplier CFM. Now rest everything, see this will change here. Now this formula will change. You have to input this formula here. See all your conditions will remain the same. See here what is happening means, okay, heating capacity you just please mute it. So heating capacity I am just hiding it, are not required here because you require the actual calculation for that. Now for water flow, what you have to do means simply you have to use the formula 104 into 2.4 GPM. So this is my water, rest everything remains the same. Now this is electrical power. Again, this value electrical power also required on the basis of what? On the basis of the report. Okay, but since we have not since we have not generated any report here, so how to calculate this? So let's calculate, let us take, see we have double the capacity here. So let us take, instead of 144, I will take 24 here. Just simple calculation. Okay. Now this I am going to copy for all the right side. So this is our basic assumption what we have done here. Okay. So why we are creating this? See, I'm just creating this one because we have to do the, we have to create one basic schematic and I'm adding this one sheet here. Okay. Now we got everything here. So we got the water flow, everything we got. Okay. So here what we can do, we can actually add one more column here. And here we can write down the total water capacity. So this particular project requires how much water? That is given here. So basically we require 2832 GPM. Okay. Now just remember this. And apart from that, okay, you don't require this. See, chiller selections are done on the basis of water flow. Now what I am going to do, I am going to directly go to this tonnage capacity here. Okay, so here what I am going to do, 1 minute, I am just changing my sheets here. So that's okay. Still we can bring this sheet here. Now, here what we can do means, here we can create one tonnage capacity, one sheet we can create here. So for the purpose of easiness, we can create this. So what I can do means, just a minute, you can just observe this. Now this is my ground floor, first floor, first, second, because we have two equipments, like in everywhere we have two equipments, third, fourth, then fifth, and finally we have sixth. Okay. Now what is the capacity in ground floor and you have to write down. One is 60. Okay, here you can see there is a dry bulb and wet bulb concept is also there. So for now, I'm just keeping it as it is here because all these values will be subjected to change according to the HAP calculation. Okay. Now 63.6, okay, is my one value. Suppose I have taken 65 here. So I need to change this value to 65. Suppose because why 65? And I will change the formula here. 65 into 2.4. So this value I need to change. So instead of 63, I have selected 60. So everywhere I need to change to 65. So I'm just following one basic. Okay. Now 65, 105. So you have to copy this 65. Okay. Now this is done. Now quantities are 1, 1. Okay. Suppose let us take the quantity as 1 and 1. Now what is the total in tonnage? You got the total tonnage of building is 1190 ton. And what is how many number of? Okay, here you can do that calculation. This into this, and this you can drag it, and this you can bring here. So this is your what you can say. This is your tonnage requirement. Okay. So we'll do one thing. Okay, this is my total capacity. Okay, we have written this total capacity. Now we got the total capacity of the building. This is my total capacity. Now what you need to do means, next we have to create this chiller schedule and cooling tower schedule. So let's bring these files together. So I'm just bringing this file together here. Okay, now how you have to create the chiller schedule, see here. Now we have calculated, we got the tonnage here 1190 TR. Okay. Now here you see what we have to do. Total building capacity in tons. So I'm just going to merge with the formula here. Diversity factor. Now we have to assume the diversity factor here. Now diversity factor is very important here because why diversity factor is important means, see, all the rooms are not going to work at one time. Obviously, all the rooms are not going to work at one time. So what we are going to do? Okay, we have to take some diversity factor. Suppose I have taken 85% as the diversity. So what is the total building capacity in tons with diversity factor I got? 101.11.5 here. Okay, suppose this is my, this is what we got. Okay. Now, number of chillers selected. Now, how many chillers we are going to select here? So that we have to decide. Suppose I wish to go with 300 TR chiller. So first what I will do, I will go divide by 3 here. So basically if I am dividing by 3 here, so how many number of chillers I got here? 337. But whether 337 chiller is available or not in market, so it's better to go with some good value like 3450. Suppose I'm going with 350 TR. Okay. So each chiller capacity in ton I'm selecting is 350 TR. Got this point? Now, quantities I am going to select 4 here. Why 4? 3 working and 1 standby. Okay, 3 working and 1 standby. Because I have selected the number of chiller as 3 here. So I am just going to write here 3. And each chiller capacity is 350 TR. So here I am going to write something like this. 3 working plus 1 standby. Okay. So quantity is 4. Cooling capacity TR is 350. Now water requirement is simple. Multiply with 2.4. Now entering water temperature. Entering water temperature to chiller. What is the entering water temperature to chiller? See, water is entering from cooling tower, right? From cooling tower, it is entering to the chiller at 45 degree Fahrenheit and leaving at 55 degree Fahrenheit. Okay. Now, what is the ambient temperature means? We have to write down the Ahmedabad city temperature. So what we have taken, let us come back to the initial point. We have taken 108.5. Suppose I am going to write 108.5 here. So this is 108.5. Now, obviously, voltage is 415, phase is 50, phase is 3, and hertz is 50. So this is my chiller selection. Next, go to the cooling tower. Same way, go to the cooling tower selector. Total building in tons is, again, you have to go back here and go to the tonnage capacity. This is your building requirement. Diversity factor, take 85% here also. Number of cooling tower, same. 3 working plus 1 standby. Now, what is the capacity of cooling tower here? Now, see, understand here. If I select chiller 350 TR, so can I select 350 TR cooling tower here, or should I go with higher side? What do you think? Can anyone say this point? If I selected 350 TR chiller, so should I go with 350 TR or should I go with a little higher side? What do you
It
think?
is enough, sir.
We can go with 350 TR only.
Yeah.
But what we are going to do means we are going to do one change here. The water formula what we are going to use here is multiply by 3. Means for chiller we got 840 GPM and for cooling tower we got 1050 GPM. Now entering water temperature to cooling tower is entering water temperature means from chiller it is entering at 95 degree. Leaving water temperature is 85 degree. Ambient is again 108.5. 108.5. Now this is again same condition here. So this is our, we have done this thing. Okay. Now what we need to do, now what you need to do means, we have done here. Okay, we have completed this. Now we got the basic idea here. So what I'm going to do, I'm going to refine this. Just observe here. So what we are going to do, we are going to take 4 chillers because we have selected 4 chillers. So 1, 2, 3, and 4. For example, these are my 4 chillers. So I'm little bit moving these chillers. Now, ultimately, what has to be done means I'm just deleting this line here because this is here we have to, actually this line what you are seeing is my supply line. So first what I will do, first I will adjust these drawings here. Now copy this. We require 4 cooling tower also. So this is my 4 cooling towers, for example. Okay. Now one line is coming from cooling tower to the chillers. Okay. Suppose this line is coming from cooling tower to, suppose it is coming from cooling tower to, okay. So this is my one line which is coming from here. Okay, now one has to return from cooling tower to chiller. But before that, let me just complete this so that we can do the actual calculations here. Okay, just a minute. Okay, done. Next, what we need to do, one line is done here. Now, here actually we have one pump here. Okay, we will be having one pump here. So I'm just, right now, I'm just making it just like that. Suppose this is my pump here. Now, one line is returning. So we also have to make, here also we have to make the header. Okay, now one line is returning from the cooling tower. So what I am going to do, from the same place, I'm going to take another line here. It is going back to the cooling tower. Suppose. Okay, now we have to distinguish the colors here. Okay, now this one loop is done here. Now suppose this is my supply line. So this is my supply line to the cooling to the chiller. So I'm going to change the color. Suppose let us make this blue line, and this is my return line. Return line. So this return line, let us make magenta color. This is my blue line. Okay, now one line is done. Next, what we need to do means, now for each and every cooling tower chillers, okay. Now what we have to do means, we have to take another line, okay, from chiller to the equipment. Now what we will do means, let us follow from here. One line is coming from here, and first let us show the connectivity to the equipment. Suppose this is my chill water, okay, chill water pipe. Okay, suppose this is going here. See, this is my chilled water pipe, for example. Actually, it will be, we can change later. Wait a minute. So suppose this is my chilled water. Okay. So this is my green color pipe. It is coming from the chillers. So what we can do, first we will make it pumps. We have to create, just a minute. We will change the color later. Now this is done. Now just what I am doing means, from the above the floor. So I'm just bringing one line here, or we'll do one thing. We'll just copy this, and we will just paste to every floor. Now this is my water supply line. Okay, now we just need to extend this. Later on, we can just delete those excess pipes. Okay. So, okay, it will not. Just give me a moment. Now here, see, here what you have to do means, see, here in this place, we have to create the pumps. Okay. So let's see how we can create the pumps here. So 1 minute. So first what we are going to do, I will take one. Now see, we require the 4 pumps here. So pump number 1, pump number 2, pump number 3, pump number 4. So if we require little bit, we can increase this. Extend. You can extend this. And suppose this is my pumps here. So this is what we are suppose creating the pump here. So same has to be copied. Okay, now we got the 4 pumps here. Now, okay, this is my suction line, pump suction line. So this is my pump suction line. Okay, now similarly, I have to make a discharge line also. So I think, okay, this is this is perfect here. Okay, now this is the discharge side. Now what happens? Now this line, what we are seeing here, this line is going to be connected here. Now one line is coming here and it is connecting to this is. So one side is done here. So suppose this is my, now see, this is my from chiller. Okay, it is going to the building. Now one line is coming back from the chiller. Okay, that we have to make now. So suppose one return line is coming from the chiller. So I'm just going to take from here only. And this is my return pipe. Okay, let us make a little more difference, like distance here. Now this is coming back here. Now, okay, here only I am going to create. Okay, let us keep it as it is for now. Let us first join this. Okay, now the same if I start copying. So let's see. Okay, perfectly it is aligned here. Okay, it is done here also. Now this is my return line. Okay, so this is my return line. Return line, and this is my return line. Now this line I am going to change color 8. Okay, we will make it color 8 here, so that now this is perfect. Now suppose here what I need to do means I need to make, now I need to do what I need to do. Now I need to create one pump here. So first we will change this color so that it can be. Now here we have to create one pump section. So the same concept I am following here. We require the 4 pumps here also because we have the 4 chillers, right? So we require the 4 pumps here also. So copy 1, copy 2, copy 3, copy 4. Okay. Now same way we will make one pump here. Suppose I'm just moving this pump out. Now suppose this is my pump. Now the direction is very important here. How it is going, it's very important here. Suppose this is my pump. Okay, whose direction is also mentioned here. Now just paste and paste here. Now again, this is coming here. Now this line is going to your chiller. Suppose it is going in this way. Okay. Now we have drawn all the lines here. Okay. Now, another important thing is we have to make a decoupler line here. Now this is done. So lines, all the lines I think is done. Now let's keep this red only. Red for the return and blue for the supply. And here if you want to change to blue, let's change this to cyan color. Maybe it will be visible. Now cyan color, let's make the cyan color. Okay, now this one I will change to different color so that it should not match it. Okay, now I think this is looking quite perfect here. Now, where we have to give the decoupler line, this is coming from here. You have to give here, I think so. At this point, 1 minute. Suppose if the water is going from here, suppose if see, I think this is the place where we have to give, but we will not give in this way. We will make it a little bit something like this. See, what is the concept? Suppose the water is coming from here, chiller going to the building. So this is my distribution flow, right? And the water which is coming to the chiller is my production flow. Suppose if due to any reason, if the water which is coming back to the chiller is more, then it will be bypassed to this line. Okay. Suppose if the water which is going here is less, so it will be bypassed to this line. So I think this is fine here. Now, only thing what we need to do is we have to create a one elbow directions. How to make it directions? I am just forgetting this. 1 minute. Not DIB. Dim. Okay, just give me a moment. We have let us make one arrows because it's very important here. Not arrows. Leader, not leader line also. We have to create the how to create 1 minute. I just forget it. No issues. So actually, I forget how to create that arrows. 1 minute. If I use the leader line is used for different thing actually. How to create the arrows? We have to copy from somewhere else. Maybe. Any idea? Can anyone just I forget it actually how to create the arrows. Like we need to show the direction here, or otherwise I will create one standard here. So suppose this is my arrow. So this is my arrow here. So I think this size is okay. Okay. So we will change this color. And this we have to now. Okay, this is the return side, right? So we have to put in the return direction. Actually, this we have to create. So, but for now, I'm just making it as it is. So we are, because this is very important here, otherwise we will get confused. If the arrows are not shown. Suppose this is these are my lines. So, okay, similarly, I will put for this also. We will just change the color. suppose these are my arrows here, and similarly this arrow also we have to give for this one, right? For this one, see, all these arrows are pointing the direction where it is going. Okay, so this is little bit important here. Now similarly I need another arrow here which is pointing in this direction. So this I am going to copy. Okay, now here I am going to take that. So this is my arrow. Okay, and this is my arrows. We will change the color so it will be easier to understand. Actually, these drawings are not in scale, so anyhow, let's okay. So this is also done here. Okay, here we have to put, and here we have to put. So similarly, this one we will copy. So if this much we will understand it. Okay, so I think this is understandable. Only thing is we require this arrows. So 1 minute. Here we need to put this arrows, and this arrows we have to put here. Now we will change the colors. Now this we have to just go and match the properties. Match the property, match the property, match it, match it, match it. Okay, we require one more kind of arrow here, which is going the downward direction, right? So this arrow also we have to show here. Okay, so this is not properly copying. So 1 minute. So what is happening? Why it is not copying properly? Okay, just a minute. Okay, next, match the property, match it, match it, match it, match the property, match it. Okay, we have to match this. Okay, this is done. This we have to match it, and this has to be match it, match it. I think this is also done here. So I think most of the places now we can understand it. Now match it, match it. Okay, one more we have left out. So match it. Now match it. This we have to match this. Okay. Now we are matching this. Okay. So I believe this is fine here. Okay, we have missed out some more. So we also require one on the return side. So let's make one more here. See this one, the return to the, okay, fine. Match the property, match the property, match the property. So I think now this is fine. So we have covered everything here. So now what we need to do means, what we have to do means, we have to just go, and now we have to write down the texting and all. So let me just write down the texting and all. I hope you are getting the point. So if you are understanding everything, just give me a thumbs up. Like if you are understanding the concept here, what we are trying to do. So, okay. Now this is my, okay. Okay. So, okay. 1 minute. So let's change this color. Yes, yes, yes. Now we will just label our, this is my, what is the capacity? 350 TR. So, okay, this is, instead of 350 TR, we will write in this way, 350 TR and 850 GPM. Okay, that will be better. No, no. Yes, yes, 840 actually, not 850. So this is my 840 GPM. The same is going to copy for each and every equipment. Now same is going to copy here also, but the texting will be different here. So this will become 1050, I think so. 1050 GPM. Now this entire we will change to magenta color. 1050. Okay, we have to change this to, entire has to be changed to magenta color. No issues. We can just match the property. Okay, it will not change. We have to enter inside and we have to change because we have not created any layers here. So not an issue because it will take some time actually. So that is why I'm just avoiding those because we need to do the a lot of calculations are there. Now this is done here. Now, okay. Okay, here we have to do some modification here also. We require the four pumps here also because we are supplying the, am I right? We require the four pumps here also because we are going with the concept of equal, what you can say, we are going with the equal, this thing, the equal capacities. So obviously we require the four pumps here also. So let us make this. Okay, now this I'm going to copy and paste. Okay, why it is happening? So some, we have to 1 minute. So that's not an issue. We will move it back. Move it back. Okay, now this is fine. Okay, so this is also cyan color, and in the same way we have to make okay, suppose this is my 4 pumps. Okay, so this is my header line actually. So let's make it little bit. Okay, now this is done. Little bit make it. Just a minute. Okay, anyhow, so this is done here. Now what we need to do, we need to also give the capacity here. See, each pump capacity is, we have to just write each pump capacity. So what I am going to write here, it's simply the capacity of pump is 1050 GPM. That's it. My each pump capacity is 1050 GPM. So either you copy and you can just paste it for each pump. This is my capacity. Similarly, here also you can do the same exercise. So each pump we can write down the capacity here also. So what is the capacity here? Here we have 840 GPM. Only thing is we need to just, okay, I will just delete this, copy. Now this is also 840 GPM. Okay, because both has to be same here, right? My supply and return are going to be same here. So I don't no need to change this capacity here. Okay, suppose this is done. Now what I need to do, see, this is my line we have written. Now we have to go for just a minute. Next, what we have to do means now we have to go with this thing actually. We have to go with the main side now. See, 850 GPM we have taken here. Now this capacity, what will be this capacity? Now see, if I come back here and if I come back here, what will be the capacity? So you have to add these three values here, 840, 840, 840. Okay, so 840 multiplied by 3, 2520 GPM. Okay, why we have taken 3 pumps here? Because there are 3 working and 1 standby pump is we have considered here. Okay, so what is the water which is going here? 2520 GPM. So similarly here also we have 2520 GPM. Similarly, this water is also 252 GPM. Okay, and similarly this water is also going into the chiller is 252 GPM. I hope you got my point. Now individually, when it is going 840 GPM, 840 GPM. Okay. So individually it will be 840 GPM. See, this will be 840 GPM, 840 GPM, 840 GPM and 840 GPM. And this one will be also 840 GPM. So let us take here. This is 840 GPM and this is also 840 GPM. Now this is done. So this is clear here. Now same way here also What is the water coming here? 1050 GPM. See, same way here also, the water which is entering here is, yes, yes. No, whether it is on or not, that is okay, but we are doing the calculation here. So we have to do all the, while doing the calculation, all has to be considered here. So 1050 GPM is coming to the chiller and 1050 GPM is going back to the chiller. So this is what we are assuming here, right? Okay, the same I am going to copy this, but I'm going to change the color here. Now we are left out with some more equipments here. So which we need to add. Okay, now this is done here. Now what we need to do, see, here we have to add one more equipment here, which is a chemical dosing. So suppose this is a chemical dosing system here. So usually we have one chemical dosing system here. So I will change the color here. And here, at this point, we have to add one system, which is an expansion tank. Okay. So I'm just adding here. So, okay, suppose I'm adding this in the sixth floor itself. So no issues. So just understand the concept here. So suppose this is my expansion tank. So I'm going to make one arc here. Suppose this is my one tank area. Okay. So this line is a pressurized system. This is an expansion tank. Let us change the different color here. So let's make any color here. Oh, it is not at all visible. That I have shared you one schematic drawing. If you remember, just follow that one only. So this one we are making, see, I will show you that also. Exactly, I'm making with that. Okay, let me make it white color here. So this is done. Now one more equipment we are missing out here. There should be one air separator. Suppose if it is coming here. Now 1 minute. If you want to see, I will show you. Just give me a moment. See, for connections and all, you just follow this diagram. This is a perfect chill water schematic drawing. So I am following the same drawing here. I am just following the same drawing here. Okay. 1 minute. See, the same drawing I am following here. Okay, but see, from cooling tower to chiller. So you see here, from cooling tower to chiller and from chiller to the equipments. So from chiller to the equipments. Now my decoupler line is between the header of these two. Okay, so air separator, yes, yes. And a specific area means air separator is installed here on the return side. Means we have to install before the pump here. So at this point, we have to install the air separator. So see here, they have installed the air separator. So I'm also going to take the somewhere here only. Suppose this is one basic diagram of air separator. So I'm just you no need to make also. That's okay. You can directly copy paste it. So anyhow, so we will write down the names also. Not an issue. Now let us keep this as a different color. I will keep it as blue color. Now, see, my drawing is perfect here. Maybe you might seeing some like some orientation, some alignment problem, but it's okay. We don't have that much time for alignment and all. So I will always suggest you to follow this diagram, and whenever you want to take any fitting, just copy paste it. But if you check this drawing here, so what I have made here, so this drawing is perfectly matching. So we have the primary pump set, secondary pump set, and we have the condenser pump set. Everything is we have considered here. So we will just write down here secondary pump set. This is my secondary pump set. This is my primary pump set. Yes, yes, I have already shared the drawing. Otherwise, I will share it today, not an issue. Primary pump set. So this is my primary pump set. And this is my secondary pump set. See, it will take very less time to create the drawings, a schematic drawing especially. So hardly we have taken this, but still we have to do some more things today. So suppose this is what we have written here. Now what we have to do means we have to also write down the water capacity which is going here means 1050 into 3, 3150 is going here. Now this is my 3150 GPM is going here. So here also it is 3150 GPM and here also it is 3150. So here also it is 3150 GPM. Okay. And returning back also 3150 GPM. Now this is done. This is done. This is done. Next, what we need to do means, see, now my pipe size is going to happen with this particular. We have to do this thing. Okay. 1 minute. Just a minute. No, we are missing out anything. No, we are not missing out anything. Now, suppose just make sure that if all these pump sets are in basement too, so you have to just little bit move your drawings and all. But right now we are not focusing on those details. Now, okay, we are missing out some things here. So I need to write down the GPM value here also. What is my 65 TR into 2.4? 156 GPM. Now this is my 156 GPM. And what is this? This is my 105. 105 into 2.4. It is my 252 GPM. Now this also has to be copied everywhere. So let us make this copy and all. Then tomorrow we will see the pipe sizing and we can create the pump head calculation for this project only. Okay, so it will be easily understandable. Now similarly, I have to also see on the return side also, you have the same capacities going. So the only thing what I need to do, just a minute. I will just change the color. This copy, paste. Now everywhere we will. Now one more thing you have to add now. Now once this is done, next, see here you have to take one capacity. So what will be this capacity? It is a collective 156 plus 252 GPM plus 252 GPM means 408 GPM. So this is also 408 GPM and this is also 408 GPM. Same you can copy and paste in every floor. Okay. Because in every floor we are assuming that same capacity is going here. So suppose this is my, okay, can keep it. Suppose this is also done. Now, next important thing is, see, we have to do one thing here. 1 minute. This riser side, we have to add the, now here we have to write down the capacity. So how to write down the capacity here? It's very simple. We have to decrease it. So now, see, this capacity will be 2520 GPM, right? Okay, first let us write down this 2520 GPM is coming here. So I will write 2520 GPM. Then you have to subtract 408 from 2520 GPM. So I'm left with 2112 GPM. So this will be my 2112 GPM. Then again I have to subtract 408 GPM. So 1704 GPM here. 1704 GPM. Then again I have to subtract 408 GPM. So it will be my 1296 GPM. Next, again, I have to subtract 408 GPM. So it will be 808 GPM here. So next, 400, 400. 888, sorry. This is my 888 GPM. So again, if I subtract 408 GPM, it will be 480. So where we are lagging here? 1 minute. It is 480. So 480 GPM is here. Then 480 is going here. That means some mistake we have done here. So 1 minute. I think some mistake has been done here. So I have to do in a simple way. 408, 1, 2, 3, 4, 5, 6, 7. 408 into 7 will give me 2856. So my capacity should be 2856. But why it is coming in this way? 840 into 3. 2856. Okay, here we have done some mistake here. So 1 minute. What is the mistake has been done here? Chiller selection we have done properly here.
Sir, actually GPM needs to be added na, from basement to.
Yes. So we actually we did.
subtracting.
No. I'm adding only. So I actually thought that this is going to match, but no issues. Let's do one thing. 408 GPM into 7 floors. 2856. So this will be my 2856. This is 2856. Then minus 408. 2448. So this will be my 2448. Then
And
again,
we can add also, na sir?
yeah, you can add also.
Okay.
2000. See, it's better to go in this pattern, because what happens if some water is left out, so at the last you can do that actually. Any 1632, I will show you 1 minute. 1632, then minus 408, 1224, 1224, then minus 408, so 816. This is 816. Then minus 408. So this is again 408. So this is fine here. So in that case, what is my pump capacity then? So 2856 is required. So I also require the same water, 2856. Okay. So what we have to do means, see, in this case, what happens? Usually what happens in this case, we will not change this value here. See, we will not change this 840 GPM because we will take this 840 GPM only. Because why we have selected 840 GPM here means, we have selected this 840 GPM in consideration with this chiller actually, chiller capacity. So totally we got 2420 GPM, but my building requirement is 2856 GPM here. In this example also, I think they have done the same concept here. See, if you see here, they require the water. Some different calculation is coming here. See what happens. If they add everything water here, they will get 596 GPM. See, this is the 596 GPM coming, but the chiller what they have selected is 408 GPM only. Why means because each chiller is having 204 GPM capacity. So the same concept they have done here. So basically what they have done means, see, they have taken 408 GPM capacity here, but while going on the top side, see, it is 596 GPM and then it is reducing here. So I think what we have done is fine here. Perfect. So we are not going to change this capacity here. I hope you understood this point, because this capacity is according to the chiller. Now what happens when the water has to go here? So they will adjust it. Automatically they will adjust it. So we are not going to change this capacity. We will keep it as it is here. 2856, 2448. Now this is the reason why we are taking one standby pump here, so that all the water requirements will be and equal capacity we are taking here. So all 4 pumps can run equally, or at least it can generate the same amount of water which is required. Okay. Now I think this is done here. So this is done. Now only thing what we require is we need to give the name to certain equipment. Like this is my air separator. So this is my air separator. So we will make it blue color. And similarly, this is my expansion tank. Now, when you talk about the expansion tank, so expansion tank calculation is always in liters. See, in this example, they have taken the expansion tank of capacity 1000 liters. So either you can take 500 liter, 1000 liter, or 1500 liter. So anyhow, that is a different story. We will see that later. And this is my chemical dosing system. Now, again, as I'm telling you that this chemical dosing and all vendor can give you the proper requirements. So it's better to get the requirement from the vendor itself. Okay. We can give the requirement. What is my water requirement? Everything we can give this. So I believe you understood this schematic drawing till now. Next, tomorrow, what we will do the pipe sizing, and each and every line pipe sizing we will do, and then we will do the pump head calculation. So for pump head calculation, we have to target only one pump because we have taken the equal capacity pump here. So if you target one pump, so it's okay. The moment you done the pump head calculation for one pump, so it is applied for each and every pump. Okay. So any questions you have in your mind for now? Okay, this line also I am going to change the color because this is a decoupler line. So it is not visible only. So any questions you have in your mind?
Excuse me, sir.
Yeah.
Yeah, now whatever we have done, this is the water cooled chiller. In the air cooled chiller, this cooling tower will not come.
Yes, yes. In the air cooled chiller, You have to just remove that. What you can say?
Rest everything will be same.
Rest everything remains same. Instead of this cooling tower, from the chiller itself, you will have one supply line, one return line.
Yeah.
See here. The same way it will be there. So still we are left out with, now we have to create the nodes here. Node means we have to give some description here. See, again, I'm telling you, just follow this schematic here. I have made this schematic only, but I have made in a very simple, what you can say, in a very simple way I have made here. So if you check this one, so you can see that they have given very properly here. So I have also followed the same thing here, but in a very simple way. So when we do the pump head calculation tomorrow, so you will have a clear understanding. We have to do the pump head calculation for one primary and secondary pump. So that way we can do that. Okay. Anyhow, we will see tomorrow. Let's try to sit little early tomorrow. Okay, I will send the message in the WhatsApp itself so that we can at least complete this calculations. Okay. So I hope you understood this, and I will share you that sample drawing also once again today, and this calculation also, so that you can have a clear understanding. Okay. Let us
सर और
do
एक
one. जी
सर उसमें हम लोग ड्राइंग में जाइए, हम लोग टेरेस से हम लोग जीपीएम कैलकुलेट करके ऊपर से नीचे आ सकते हैं ना, ऐड करके
हाँ, आ सकते हैं ऊपर से नीचे.
लेकिन मिडल में आप वो इंक्रीज किया है, बाद में रिड्यूस हो गया है,
1
2741 हो गया.
एक मिनट, इसका नाम चेंज कर देता हूँ मैं. कौन सा बोल रहा हो आप?
फिर वही आपको ड्राइंग.
एक मिनट.
ये चिल्लर का आउटलेट कितना आ गया, 20.
दिस वन 2520.
वही सर 25. नहीं सर वो ग्रीन लाइन वाला जा रहा है ना उस फ्लोर को, नेक्स्ट उसमें 2858 हो गया, इधर 20.
400 गया, फिर 2448 हुआ,
नहीं
फिर
सर, नहीं
400
इधर
गया.
में चिल्लर से आउटलेट आ गया 2526 है, चिल्लर से आउटलेट सर, ग्रीन लाइन नीचे नीचे.
हाँ,
हाँ इधर
2520.
2520 होने के बाद में इधर सडन इंक्रीज हो
हाँ,
गया है.
this what we have done means, see, ये 2520, this GPM is while selecting the 3
वही
के हिसाब से ले लिया है.
ओके.
But this 2856 is the collective sum of all this AHUs. मतलब
तो
ये
सडनली
जितने
इंक्रीज
भी,
हो गया तो पाइप साइज इंक्रीज हो जाएगा
it
ना
will
उसको.
increase. See, in this example also they have taken the same way, and this is the approved drawing. See, basically in this drawing, if you see, suppose these are the equipments. Here they have selected 204 GPM, means 408 GPM. One line is 408 GPM. But when you see the main line, header line, they have suddenly increased to 596 GPM here, because this 596 GPM is the collective sum of all these equipments. But this 204 or 400 GPM is the capacity of this pump here. So this is what is the concept actually in chilled water drawing. Yeah, pipe size will change. So that is why यहाँ पे क्या होगा आपका, मान लो कि मेरा 2520 GPM है ये, अगर इसका कुछ आ रहा है 8 inches for example, so if this is becoming 10 inches, no problem, because here water requirement is more here.
मैं और एक सर मैं क्या पूछ रहा था, अभी हम लोग का 6 फ्लोर से नीचे आ गए तो हम लोग का ये अराइव हो जाएगा ना, ये 2056
See, if you are coming back
ऊपर से आएगा
down,
तो हम लोग.
ऊपर से भी आ रहे तो आपकी कैपेसिटी बढ़ता जा रहा है, बढ़ता जा रहा है, बढ़ता जा रहा है. So basically 2856 GPM is going here, but
लेकिन इधर इंक्रीज करना पड़ेगा हम लोग, इधर
no, but our
डिक्रीज
pumps
करना
are,
पड़ेगा इधर.
yes, but we are taking 3 working and 1 standby, so it is equally dividing here. So ultimately, when it is coming into the pump here, it is going
सर और एक मैं क्या पूछ रहा
25
हूँ,
20 GPM only.
2856 को 4 में डिवाइड करेंगे तो ये इक्वल हो जाएगा क्या?
No, you cannot divide in 4 because 3 working
Hmm.
and 1 standby. Always you have to divide in 3. आप वैसे भी कर सकते हो, प्रॉब्लम नहीं है। अगर आपको वैसे करना है तो यू हैव टू इंक्रीज द पंप कैपेसिटी हियर 952। बट अगेन 952 जीपीएम अगर आप लोगे तो आपका चिल्लर का कैपेसिटी भी बढ़ जाएगा, आपका 396
ज़्यादा
400 टीआर हो जाएगा ये। मीन्स अल्टीमेटली व्हाट यू आर डूइंग मीन्स यू आर टेकिंग 1200 200 टीआर एक्स्ट्रा ले रहे हो आप, तो ये client will not bear this extra amount. So that is why what is the concept here means now here what you are doing means here you are taking the variable pumps in secondary. So pump will adjust according. Now compulsory it is not required that 2856 is always going. Okay. Always this 2856 is not going to go into the building here. Sometimes some water
Okay.
requirement will be less here. So this is the concept actually. I hope you got my point.
Okay, sir. Okay.
Yeah. So anyhow, tomorrow we will complete this calculation. Like, see, how we have to do the calculation pump head means same concept, like how we have following in firefighting or plumbing. We have to always assume that this is my last equipment. Okay. From here, we have to do the pump head calculation. So if water can reach, if I have to supply water to this particular AHU, what is the pressure required? If water can reach this AHU, it can reach anywhere. So this is the concept what we are following here. So same way what we will do means here what we are going to do means see, if you check this, here we have to create this something like this we have to create. We have to give the section here. Section A, B, C. So this is the standard section. Primary pump will not change, but your secondary pump will change here. Okay, so that first we will develop this, or I will try to develop this before the class itself, just to avoid, just to means speed up our time, and then I will explain you. So your design is successful only when your decoupler line should be the same description. Like here you can see my H description is this decoupler, and here also my H description is decoupler. So your decoupler line should be always the same description. If it is okay, then your design is perfect. Okay, means your pump head is perfect here. Now, to make this schematic drawing, it will take hardly 1 day. At least 1 day is required. Suppose if you are talking about 8 hours duty, so you can just take this reference, okay, and you can just copy paste, and you can make it properly. So this is one of the concept where my chiller plant is in the basement and cooling tower is in the top. Suppose if both are in terrace, again the drawing will be same only, but you have to little bit modify the design here. Okay, so that thing comes with the engineering part here actually. So anyhow, not an issue. So tomorrow we will do the pump head calculation. So this is my chilled water schematic drawing. And similarly, after that, we will see the VRF designing also. And VRF schematic is very simple actually. So you have to like, it's similar. It's simple, means the same way we can develop that also. That's not an issue. So I'm just changing this color to cyan. Okay. So anyhow, let's stop here for today. So thank you.
Excuse me,
Thank
sir,
you.
one thing. And
Yeah.
we are discussing this out, no, that a power supply required for this pumps and all.
Actually, that is completely the electrical topic, actually, electrical part. So you have to understand little bit basic concepts for that. But let's see.
Because that chiller splitter panel and also 2 circuit is required for each chiller, that kind of we're discussing.
No, normally what we are discussing in electrical, you can follow that concept, no issues.
Mm-hmm.
So everything is like usually, see, you already know what are the things has to be understood for
Yeah.
doing the like cable sizing. There are a lot of factors to be considered. We are already discussing that. So
Yeah.
all those things again we have to restart it. So here also what you have to do means it depends upon the power only. So ultimately tomorrow when we do the calculation here, so we will get the power rating here.
Okay.
So depending upon that power rating, we can calculate the cable sizing. Same way, same
Like,
formula we have to
yeah,
apply.
yeah. But that
Cable
like, thing
sizing.
is like how we select this panel for the chiller. Like two circuits is required if the capacity is more than maybe 150 TR, like that that and all.
That everything in electrical, when we do the panel sizing, we can understand that.
Okay, then fine. The same thing will come in the electrical when we do that.
Yes, yes, exactly.
Then fine, then.
Okay.
Okay, okay, thank you.
So, okay, let's stop here for today. So tomorrow we will go a little bit early, like 8:30 or something like that, or 9 p.m. so that at least we can complete the maximum part of it, because we have to do primary, secondary pump calculation, and condenser pump I think is okay. It's very simple to calculate. So let's see, and let's because we have to also see the pipe sizing. So I will do all this sizing and all. I will make it little clear, and then I will explain you so that we can save our time. Okay. So okay then, let's stop here for today. So thank you. Thank you.